That's actually going to be kind of an interesting one for reasons we'll find out. But for now, we'll take a look at seatsInTheater. Okay, so it looks like we got a nice picture here that's worth 1,000 words. So let's just try to get through this 1,000 words first. Your friend advised you to see a new performance in the most popular theater in the city. He knows a lot about art, and his advice is usually good, but not this time. The performance turned out to be awfully dull. I can relate. It's so bad you want to sneak out, which is quite simple, especially since the exit is located right behind your row to the left. All you need to do is climb over your seat and make your way to the exit. The main problem is your shyness. You're afraid that you'll end up blocking the view, even if only for a couple of seconds, of all the people who sit behind you and in your column or the columns to your left. To gain some courage, you decide to calculate the number of such people and see if you can possibly make it to the exit without disturbing too many people. Given the number of rows and columns in the theater, and rows and end columns respectively, and the row and column you're sitting in, return the number of people who sit strictly behind you and in your column or to the left, assuming all seats are occupied. Okay, cool. So, any questions about what we're doing here? I mean, I think this is kind of a considerate person, right? It's someone who's not enjoying the performance, but despite it being awfully dull, still doesn't want to disturb all these other people. Doesn't even want to block their view of this awfully dull production for even a second. So that's kind of nice. Now, one issue I have with this is basically the guy's worried about disturbing the people behind him, right? I think this is the idea, or yeah. Let's see. So, given the total number of rows and columns, number of people, they sit strictly behind you and in your column or to the left, to your left. So like if you're sitting here, you're facing this way. So, if you rotate your head around for a sec, basically your left would be, here, hold on a sec. We're just gonna have to modify this for a second. Let's make this, we'll keep it visual. So here's you. You're kind of standing here because you're getting ready to go. So there you are. Okay, so you were looking at the screen, right? So you were looking like this way, looking at the screen. And so if you want to turn to your left, it's basically going to be this way, right? So when they talk about your left, they're basically talking about like what would appear to be our right if we're looking at it from this perspective. So I guess that's part of the exercise here. But anyway, the point is, I guess one thing that could be a bit confusing about this one is, even though this guy is worried about this guy back here being disturbed by seeing him leave, he doesn't seem to be concerned about like all the people he would have to walk over to get out of his own row. So I don't know what that says about the guy. But anyway, the point is, we've got a visual here. We have an idea of how we're going to do this. So basically, let's do a counter here. So we'll call it disturbed. Let disturbed be assigned the value of 0. And at the end, we're going to return disturbed. And it's basically going to be the number of disturbed people. And I guess we could have called it that. We could have said let number of disturbed people be assigned the value of 0. But it's getting to be a lot, kind of a long variable name. So it's good to have descriptive variable names, but like within reason. Come on. Anyway, so, okay, we're taking a look at this example here. The row is row number 3. I guess these are 1 based, right? So this would be row 1, row 2, row 3. And then over here, this would be column 1, column 2, column 3, column 4, column 5. And I guess there are 11 rows, 16 columns total. And we start at 1. So I guess this one would be column 16. Okay, so let's do a double loop here. You know, let's say let I be assigned the value of, this is going to represent rows, so it's going to be assigned the value of row. I want to say while I is less than n rows, yeah, I plus plus. And for let j, we're doing a nested loop in here. This one is going to be for the columns. This is going to be our column index. So we want the number of columns, j plus plus. And then once we're in here, we basically want to say, I guess just disturb plus plus, right? That's pretty much it. Is that going to work? No, that's not going to work. So why did that one not work? Well, is it because we're not going far enough? I mean, these are one based after all, right? So if we're starting at this row, we should probably include the final row and include the final column. Is that going to work? No, we have too many now. The thing is, keep in mind, this guy doesn't care about his own row. He only cares about people behind. So maybe this one needs to be one less than. And there we go. Okay, so is this going to work? Can we submit it? Are we going to have any huge variables? Okay, I guess it's going to work. Good stuff, good stuff. We're 2% of the way there. Feels good. All right, so thanks for that. Let me go back over here. I want to take a look at the guaranteed constraints just to see what kind of stuff we're looking at. I mean, technically, maybe I should have taken a look at that earlier, but there could be 1,000 rows and columns, and you know, we could start at any position within there. So it could be that it's like 1,000 by 1,000 and we're starting at 0, 0. That would be like worst case scenario, in which case this, the plus plus here, would iterate 1 million times, 1,000 times 1,000. 1 million is a lot, but I mean, it's not totally unreasonable. It's not like it's like 1,000 billion or something like that. You know, like we can get that done. Well, obviously we did. It passed all the hidden tests and everything. Okay, so basically, we're going to try this again. We're going to try a different approach here because there's something that we can notice. I mean, basically, we've got this double loop here, and it's just adding 1 each time. So instead of all this, because it's basically going from call to n calls inclusively, right? So that would be kind of like, okay, so the number of columns here was 16, right? Yeah. And then we had 5 over here. That was the one where we were starting. So could we just do 16 minus 5? Would that work? Well, what would that give us? 11? Let's count them. Let's just make sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we'd have to add 1. And I guess that makes sense because it does include this column that we're starting at. There are only 4 that we'd want to cut out here. So 16 minus 4, yeah, it's 12. Okay, so basically for this, instead of just going through the loop and doing disturb plus plus, let's cut out the middle then. Let's say disturb plus equals n calls minus call plus 1. Let's try that. Is it going to work? It's going to work. Okay, very nice. So, well, that's a bit better, right? I mean, now we're just down to 1 loop. This would fire off a lot faster. And, you know, we could even like make a constant for this or something like that, you know, call it width or something like that. Like here, width. It's giving me a green text there just because we haven't defined width yet, but let's just say it's that. And now when we run this, I would argue this is probably slightly more efficient because it's not like we have to recalculate this value each time. Now we have a constant. It's not going to change, and it knows it's not going to change, which means it's not going to take up as much memory as a different type of variable like a let, which has the ability to be reassigned. Okay, so this is good. This is definitely getting better. But if you think about it, there's nothing stopping us from doing the same sort of thing to this loop, you know? Like we have this one that was firing a predictable number of times. We have this one that's also firing a predictable number of times. So we could also say something like const height is assigned the value of n rows minus row plus 1. And then maybe we could just, instead of this being a loop at all, we would just say disturb plus equals width times height. Let's try that. Is that going to work? And no, because keep in mind, we don't include the row that we're on. We did include the column that we were on, which is why width had a plus 1. But since we don't include the row we're on, we're not going to put the plus 1 on that one. And now that's going to work. So that's good. we could simplify this. You know, we could say, we don't need to say disturbed is 0 and then disturbed plus equals. We just say, well, let disturbed be this. Don't need this initial declaration. We can just run that, return disturbed. Then again, why use a variable for something that we're just returning right away? Why not just say width times height, return width times height. Let's try that. Hey, not bad. I mean, really, if we really wanted to cut this down, if we wanted to make this as short as possible, as brief as possible, we could just do something like this. Go right for the return this thing, that's our width, multiplied by our height, which was this thing, n rows minus row. Close that up, and let's delete that, run this, and there we go. Okay, so that's probably a little more efficient. Let's just make sure it passes all the hiddens. It does. Oh, and by the way, when I say that's a little more efficient, I should point out, because we were talking about, like, the worst case scenario where both of these are 1,000 columns, 1,000 rows. We're at the very bottom left, 1, 1. Well, in that case, like we said, this operation will happen 1 million times. So it's kind of like, well, it's like big O of, n calls minus call times n rows minus row. It's kind of like comparable to like what you call big O of n squared typically. But in this case over here, this is big O of 1. It's constant time. No matter what, this is done. It's just one operation. That's it. You just pop it in once, it's done. We don't need to worry about any loops here. We don't need to worry about the time complexity. We don't need to worry about like the computation time scaling up according to the size of our inputs. It's just constant. It's not going to change. Okay, cool. So we submitted this, right? We're all done, I think. Yeah. Let's just be sure. Yeah, okay, cool. All right, we'll finish up with that one. Nice job, everyone. That was fun. Okay, cool. So the last one we're going to